Hi there, hope you have a fantastic day today. This lesson I will teach you projections of vectors. Of course, there's a PDF file version on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Let's say there is two vectors. So let me just draw this out. So this is vector v and this is vector u. And the angle between these two vectors is theta. So let's say there is a sun over the head of vector u. So therefore, the shadow of u will be onto vector v. So this is the shadow of u. So let's name this vector here is vector p. So this shadow here or vector p is known as projections of u onto v is equal to p. Okay, so projection of u onto v, in another word, we find the shadow of u onto vector v. That's all. Okay, so we can easily find the projections of u onto v. So first of all, what we can do is we focus on the right angle triangle. So we find the scalar first of u onto v. So that is the magnitude of p, if you like. And then we find the directions. So we know that the vector p has the directions exactly the same as vector v. So therefore, this is equal to the magnitude of p, and we times by the unit vector of v. Because if we times unit vector v, it will give us the directions. So unit vector v is vector v over the magnitude of v, okay? Because unit vector is a vector that has one unit. So therefore, just the vector over the magnitude itself, okay? So please keep that in mind. So first of all, to work out the scalar, so the magnitude of p here is known as the scalar of vector u onto vector v, if you like. So that's what that meant. Now to find this, we just focus on the right angle triangle using right angle triangle trick. So this is the magnitude of u. So we have adjacent and we have hypotenuse. So which is car. So cos of theta. So let me just write this down. So cos of theta will give me adjacent, which is the scalar of u onto v over the magnitude of u. So let's name this equation number 1, okay? Because we're going to use this later. And we know that u dot v, so u dot v is give me magnitude of u times magnitude of v and times the cos of the angle in between. And let's name this equation number 2, okay? Now, if we substitute equation number 1 into equation number 2, because this cos theta here is equal to this. So let's replace cos theta with magnitude of p over magnitude of u, okay? So that will give me magnitude of u times magnitude of v, and we times the magnitude of p, that is the scalar of u onto v, okay, if you like. And of course, we can simplify this by cancel this out. So therefore, u dot v will give me magnitude of v and times by the magnitude of p. If I divide by both sides by magnitude of v, so to get rid of this, I divide this by magnitude of v, I divide this by magnitude of v, so this cancel out. So therefore, the scalar of the vector u onto vector v, that is magnitude of p, is equal to u dot v over v magnitude. So therefore, the scalar of vector u onto vector v is u dot v over magnitude of v. Okay, so please keep that in mind. So now let's just refer back to this. projection of u onto v is equal to this. So now we can just replace the magnitude of p with equations. So the projection of u onto v is, we know that the scalar times by the unit vector of v, because we want the direction of v, okay? So now we just substitute this in. So the scalar is equal to u dot v over the magnitude of v times by the vector v over magnitude of v. That is the unit vector. So please keep that in mind, okay? Or you can write like this as well. So u dot v over, so magnitude of v times magnitude of v is equal to magnitude of v squared. Of course, we times by vector v. So that is the projection of u onto v, okay? So let's go through a couple examples. So first one, so part A, we need to find the scalar projections of u onto v. So first of all, so we know that the scalar projections is just the magnitude of projection, if you like this. And the magnitude is equal to u dot v over the magnitude of v. So therefore, the scalar projections of u onto v, so we just write u dot v first. So that give me 2i plus 3j dot 3i minus 4j. To find the dot products, so what we do, we just times the I components together, and then we plus the product of the j components, okay? So 2 times 3 is 6, plus 3 times negative 4 is negative 12, so minus 12. So that will give me negative 6. Now we just need to find the magnitude of v. So we have v is equal to 3i minus 4j. So the magnitude of this is 3 squared is 9 plus 4 squared is 16. Square root of that, of course. So 9 plus 16 is 25. Square root of that is 5. Now we just substitute this value in. Now the scalar projections of u onto v is equal to u dot v is negative 6 over 5. And please take note, the scalar can either be negative or positive, okay? Depend on the dot products of u and v, okay? So please keep that in mind. Now part B, so we need to find the projections of u onto v. Now remember, the projections of u onto v is equal to the scalar, I just name p, okay? And we times by the unit vector of v. So that's what it is, okay? Or can be written as, so u dot v over magnitude of v times the unit vector of v. Or you can even write everything all in one line, okay? Keep that in mind for me. So u dot v over magnitude of v square times by vector v, okay? Whichever way you like. But we already figured out the scalar projection of u onto v. So that is, so the projection of u onto v is equal to, so the scalar is negative 6 over 5. That is this one here. And we times by the unit vector of v. So the unit vector of v is 3, negative 4. So 3i minus 4j over its magnitude, which is 5. We already figured out earlier. So that will give me negative 6 over 25 times by the vector v, 3i minus 4j. So there you go. Otherwise, you can just use this formula. Just do straight away if you like, okay? Please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through them with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So we know that the scalar projection, so the projections of A onto B, the scalar projection, okay? So which is equal to A dot B over the magnitude of B. So first of all, let me work this out first. So A dot B will give me 4I plus 3j dot 2I minus 2j. So now we just times the I component together. So 2 times 4 is 8. And then we plus the product of these j component. So that give me -6. So minus 6. And 8 minus 6 is 2. So that is 2. So now we need to find the magnitude of B. So magnitude of B is equal to, we have 2 squared, which is 4 plus -2 squared, still give me 4. We add them up. So that give me 2 lots of 4, correct? So that is 2 square root of 2. So if you're not sure, you can just simplify by this. So that will give me square root of 4 is 2 root 2. Okay, so that's what it is. So now I just substitute that in. So that will give me A dot B is 2 and the magnitude of B is 2 square root of 2. Of course, we can simplify this. So that give me 1. So that is 1 over square root of 2. And of course, I can just rationalize this by times by square root 2 times square root 2. So that will give me square root 2 over 2. So there you go. Part B. So the projection of vector U onto vector V is equal to the scalar, that is U dot V, over the magnitude of V times by the unit vector of V. And we already sort out the scalar vector. So that is root 2 over 2. So root 2 over 2. And we times by the unit vector of V. So unit vector of V is 2I minus 2j. That is vector V, 2I minus 2j over the magnitude of, and that is 2 square root 2. So that will give me, of course, this one, I can cancel this out. And we have 2 times 2 is 4. So that is equal to 2I minus 2j over 4. Of course, I can factorize the numerator. So that will give me, I take the 2 out, and that give me 2I minus j over 4. And this can simplify further, that give me 2. So this is equal to a half, if you like, I minus j. So there you go. I hope you got all of them correct. Thank you so much for watching. Bye.